Hello. Hi. My name is Mark Masterson. Welcome to Lightning Components in Redux, a predictable state container for Lightning apps. I'm sorry for running a little late. I was on a Dreamforce shuttle that was stuck in traffic, and I even tried to get them to let me out on a Howard and 4th, and the guy wouldn't let me out. And I was like, it's right there. And so I had to go all the way around the block. So that was a fun adventure. So welcome, and thank you for your patience. Dive right in. My name is Mark Masterson. I'm a lead applications engineer at Canandy. Canandy is an end-to-end ERP built natively on Salesforce.com. It's pretty awesome. We have a booth in the Cloud Expo, so if you have some time, come visit them. They clothe me, literally, so it'd be cool of you to go visit. And you can find me on Twitter at MarkMastersonSF. And you can find Canandy at Canandy. This is your don't count your chickens before they hatch slide. I don't have any forward-looking statements, but it's a vital part of your Dreamforce experience to always get your safe harbor slide. So that's included just for fun. All right, I know most people here know what Lightning components are because you're at a Salesforce conference. But how many people know what Redux is? Off the bat. Okay, so quite a few people, but not everyone. So I will dive into a short introduction. I'm going to try to do things a little quicker because of my lateness. So just to give you an idea of what Redux is, it's a state management library. It was written by Dan Abramov at Facebook. And it was originally written to use with the React view library that Facebook uses to build their user interface components. But the good news is that Redux is completely separate from React, and you don't have to use it with React. And people have already written bindings for Angular, for Ember, Angular 2. So I took on the mission of writing some bindings for Lightning components. And that's what this talk is all about. The motivation for writing Redux is that Dan had a lot of inspiration from the Flux architecture that Facebook uses, and as well as the language Elm. And the real motivation is that there's just a lot of complexity in managing state in JavaScript applications today. And I think a large part of that is due to a lot of the reasons given in the slide, like the asynchronous nature and just generally managing state. But I also think like these component-based architectures result in a lot of complexity in state because each component's kind of creating their own state. And once you have like 10 components, you're already starting to look at 10 different states to manage, and it just starts to blow out of proportion once you get to like 100 components. That's a lot of state to think about. The way Redux handles and makes state less complex to handle is 3 principles. It's a single source of truth, state is read-only, and changes are made with pure functions. Now, each of these 3 principles match up to one of the core pieces of the Redux API, which is pretty simple. And I'll go through all of those pieces. There's other pieces to the API, but they're all kind of utility functions. There's 3 main parts. There's actions, reducers, and stores. Oh my. Your store corresponds to the single source of truth in the 3 principles. It's a JavaScript object that is your entire application's state graph. You have a couple helper methods with this store. You have a get state that you can access to get to the current state of your application. You have a subscribe method, which you can call with a listener. And whenever there's a change in the Redux store, that will call that as a callback, that listener. You update the state with actions. So you dispatch an action to the store, and that will do your changes. And what that does is it runs the reducer. So you have this create store method, and that ends up creating your store. And you pass a reducer to that method, and that will run all the reducers when you dispatch an action. So actions, they're plain JavaScript objects, and they're processed by the reducers to produce the new state. As I said earlier, you call store.dispatch. The only requirement for a Redux action is that it implements a type property. And that's the only requirement. It has to implement that. You can pass additional parameters as a payload to the reducer to process additional things, but the type is the only one that's required. And there's the notion of action creators. And typically in your actions, you don't have any asynchronous code or side effects. And with action creators, you return a Redux action and you can process all your asynchronous logic within there. And then reducers, they're pure functions, so they have no side effects. So whatever you pass into there as a argument, it will always return the same result. So that's the key. It cannot have side effects. That's what allows Redux to be predictable. Now, you only pass one reducer to create store. So if you want to have multiple reducers and split out your logic and not just have one massive reducer that controls all your business logic, there's a utility method called combine reducers. What you do is you make all your different reducers, you feed them into combine reducers as an object, and each key in that object becomes a name in your object graph. And then you pass that root reducer that comes out of combined reducers into the create store. So that's the brief introduction to Redux. Getting into what I've done with the Lightning Redux bindings. I have this in a GitHub repo. It's open source. I'll have the link at the end, and I'll post it in the chatter feed for the session afterwards. But the main way I'm binding Lightning and Redux together is with this provider component. So my main goal with this was to do this with as little extra libraries as possible. So I'm just using Redux as a first go, and then I have an example and demo later where I use Webpack. And I think that would be the end goal if you're going to do something like this, is to use something like Webpack or Browserify to package everything together. But that's a whole separate talk, so I'll go over it briefly later. But that's the direction I'd want to go. But it kind of opens a Pandora's box in terms of like things you need to learn in Webpack configurations and NPM. But so with this library, you can do a Lightning component in Redux today with this library without learning any of that. The main part of the provider component is the store attribute, and so that's where we're putting the Redux store. And then we have a couple of different Lightning events that we're firing and handling on the provider. And I went to JF Paradis's talk yesterday, and a lot of these are application events, so I think you would yell at me because you're saying to use component events always. But for example, this Redux store change, that's in the subscribe call. So whenever there's a change in the Redux store, it fires a Redux store change Lightning event out. And the idea is that whenever you would want to detect a change in the Redux store, you would handle that Redux store change Lightning event in your Lightning component and then map the store to whatever attributes you want on that Lightning component. And I'll demonstrate that later. The other ones it handles is a store initialized Lightning event. You can either pass the store as a parameter in that Lightning event to initialize the store into the provider, or if you set the store directly on the provider component, you fire the store initialized event just to let all the other components know that the store is ready and to let the provider component initialize it. And then finally, there's a dispatch action Lightning event, and that's what you send an action as a parameter on the dispatch action Lightning event. And when you fire that, the provider component handles it and dispatches that action on the store. If you go the Webpack Browserify route, you can end up getting rid of the dispatch action Lightning event using bind action creators, which is another utility method that Redux provides. And I'll show an example of that later. Some of the add-on utility functions to use this out of the box without using any other libraries. I provide a reducer component. It's an abstract component that you extend yourself. You set a name on it, and that will determine the slice of the state graph that the reducer controls. And then you call it import reducer event to this other add-on component, the root reducer. So this kind of is a way of using all the combined reducer functionality that Redux provides. And I'll show an example of that later, where you use a root reducer and you put the reducer components within it. And that calls combined reducers, and then you send that store that results out of that and create that store. So enough slides. Let me get into some demo stuff. So I got plenty of code to show, and I'll try to go through this quickly. So the first example I'm going through is a very simple counter example. It's just your basic counter. I'm doing this to just kind of illustrate how this is done. So it's really simple. If we dive into this, and this is the actual repo right here, so if you want to take a look at it, I have all the examples in the repo. There's this simple counter example. This is just one Lightning component. Can everyone see that? Cool. So this simple counter, it imports, sorry, someone say something? Okay. So it imports Redux. It calls after Redux loaded controller action. We have the store object. We have a counter attribute, which is an integer. And then we have our two UI buttons that do a click increment and click decrement. And then we output the counter attribute. Now to take a look at this controller, you can see our after Redux loaded event we're calling. This is where we're setting up our store. So we know that Redux is loaded. We set the store attribute, and we call the create store method of Redux. And we're passing our reducer, which we have in the helper. So this helper.counter method is our reducer. Then we're setting the store, or we're getting the store, and then setting the counter to the store. And then you can see here where I'm setting up my subscribe call to handle changes. So whenever a change in the store occurs, this handle changes gets called and sets the counter attribute to whatever the state of the store is. And then the click increment and decrement functions pretty much do the same thing. This increment function, I mean, they do the same thing, but opposite. The increment function is an action creator, and it's just simply returning a Redux action, which has a type of increment. And then it is getting the store and calling dispatch on that action creator. Now what happens when that gets called is it goes into this reducer function, which you can see takes state and action. So whenever we dispatch an action, this gets called with that action. So it gets called with the action.type. We have a switch statement, and we have a case of increment or decrement. And the current state gets fed into this reducer. And here we're just simply returning the state +1 or -1, depending on the action that's called. And then as a default, we're setting it to 0, which is why it's initialized to 0 when it first comes into the app. So very simple example, but not very exciting. To get just a tad more exciting, we're going to introduce a little bit of shared state. So now we have what we're calling the complex counter example. We have 3 different counters, but they're all sharing the same state. So if I decrement 1, all of them decrement. And if I increment 1, all of them increment, because they're all sharing the same store. But they're all 3 separate Lightning components. And to show that to you, we have this complex counter component, and this is kind of serving as a container for the store. So you can see here, it's registering the store initialized event. It requires Redux and requires the provider, which I was talking about before. And then it has these 3 counter Lightning components. And the controller looks very similar to the simple counter after Redux loaded, where we're just setting up the store. The one big difference is that we're firing the store initialized event, which lets the provider know that the store has been fired, and it lets any other components that are relying on the store to know that the store is initialized. And then the counter reducer is the same as in the simple counter. But just to show that to you real quick. And then the counter is kind of doing what we were doing before in the other portion of the simple counter. So we're really just breaking it up and using that provider as a container for the store to communicate with all the other Lightning components. So you can see here, it's handling that Redux store change event, and it's registering that dispatch action event. And then it just has the counter attribute on it. And then the increment and decrement is the same as the simple counter. And then in the counter controller, you can see in the handle store change, that gets fired whenever there's a change in the Redux store. And we're getting the param of the store and just setting the counter attribute to the get state. And then these are pretty much the same as the simple counter, except we're calling the dispatch action event, which sends the event to the provider component, which handles it and takes care of the dispatching of the action on the store for us. Now, we've kind of gone through a little more complex shared state example. Now I'm going to go into everyone's favorite UI app, which is a to-do app. It's the favorite app to do. No one? To-do app? No? Okay. And now I've used a couple of SLDS here, so we'll kind of ignore all that, but I just wanted to make it a little more pretty. We have a couple of to-dos here. This is backed by a to-do object in Salesforce, and it just has a text field on it. It's not anything fancy. But we have a couple different controls, so this is a little more complex of an app, just to demonstrate what you can do with Redux and Lightning components. And I'll dive into this real quick. And then I want to get through this, and then I built the same app using Webpack. And all this code is on GitHub, so you can kind of go through it yourself, because I won't be able to give you an in-depth. But the to-do app, let me clear these guys out. The to-do app has a couple different things going on. The main things to look at are this to-do app, which is kind of the container for the whole thing. You can see I'm importing SLDS here. We have the provider component, and we have this to-do store component. And then we have a couple different other components that we're using to do the visibility filter, to add new to-dos, and that representation of the to-do list, which has an underlying to-do item that is in the Aura iteration. To show you how this is all kind of wired together, this to-do store component, it's nothing visual, it's all back-end. It has that root reducer that is one of the add-on utilities. It requires a Redux, has the reducers combined event. So when this root reducer combines all your reducers together, it fires reducers combined, which then you can handle in a container component, and then you send the store initialized event to your provider. Now to show you where there's a big win with using Webpack versus kind of this setup, I'll go to the to-do item. And now the to-do item has a lot of things going on. It has a checkbox here. There's a checkbox that has an edit mode. You can edit them, you can delete them. And to kind of show you what one of these controller methods looks like, we'll go to the update. And you can see I'm getting an update to-do, which is backed by a to-do controller in Apex. And then we're doing an edit to-do action creator. And what we're doing is we're getting the to-do, we're setting it as an action param, and then we're sending it the typical flow for doing an Aura-enabled call out. And then in the success portion of the callback, that's when we're dispatching our action to the provider here. So here you can see I'm actually setting the param to this edit to do, and that's getting sent to the reducer, which is in this to-do reducer helper. So when that gets fired, it gets sent into here to edit to do. So first we go make a call to the server, we edit it. When it's successful, then we edit our Redux store. And we just do this state.map, which returns a new array, so we don't actually mutate the state. And we just set it to our new, what we edited it to in the action. Now to briefly get into how Webpack and Browserify simplify this a bit, we'll jump to this Webpack to do. And the big difference here you can see is we have our SRC folder and a Webpack to do folder. And that's where I'm keeping my kind of separation of concerns between what I'm doing with bundling. So what Webpack and Browserify do, if you're not familiar at all, is they allow you to write more modular JavaScript, and they'll take dependencies that you have and bundle them all into one JavaScript file. Or multiple if you're using code splitting, but I don't want to get too crazy. But the idea is that you have one JavaScript resource that you can import into Lightning, into Salesforce, which really allows you to write more modular JavaScript code and then bundle it all together and put it in as a static resource. And that's what we're doing here. Just to give you a brief preview of what this Webpack config looks like. We have an entry point. That's our base file, which all the dependencies that go into that entry point will get bundled together. We're picking a file name of webpack to-do.resource. That just makes it easy to load it in as a static resource. And then the big thing I'm doing here is I'm making a library name of a Webpack to do. What this allows me to do is use that code that I've done and that I export out of this within my Lightning components. So here you can see I have, instead of having all those actions and reducers in my Lightning components, I have an actions folder and a reducers folder. And I have my to-do reducer broken out just into a JavaScript file instead of being inside one of the Lightning components. And I'm exporting this so that when I call this in another file, like this index here, what this index is doing is importing the to-dos from the to-do reducer and the visibility filter from there, and then doing the combined reducers here instead of having a Lightning component that takes care of that action. So instead, we're doing it all within the static resource. And then that also allows us to take some advantage of like using NPM to manage our dependencies. So we're using Redux. So instead of always having to worry about getting the latest UMD Redux, we just NPM install it, and we can use NPM upgrade to upgrade it when we want. And we can use all that nice package manager functionality that we have with NPM. And then I'm also using a concept that I didn't want to get into too much, but Redux has a notion of middleware, which allows you to customize how Redux works. And the one I'm using is Redux Thunk. So typically an action can only be a JavaScript object, but if you use Redux Thunk, that allows you to have asynchronous logic within your action creators. And just to get into what that looks like, I'll go into my actions here. You can check this out on the GitHub repo later. But I'm actually setting up all I pass in a component to these actions now. That lets me get to my Lightning component API goodness, like my get and my set. So when I pass in the component here, I can get all my controller actions. I can set this all up. The big thing to know is that when you do a thunk, you have to return a function that has dispatch as an action. and then you return your action out of this dispatch. So it's very similar to the setup before. What it's allowed me to do is I don't have to stick all of these actions in one file. I can separate this out even more, make the logic much more succinct. And then if we come into the to-do item in the Webpack to-do, it makes it a lot more lightweight and easier to understand. So if I come into this Webpack to-do item in the controller, you can see instead of all that code I was doing before with action.callbacks here, I've moved that out into the static resource. And instead I'm just calling Webpack to-do.actions, which we're exporting, and then the edit to do, and I'm passing in the component from here. So that's a very brief overview of how that's working. I'll be happy to go over this more with anyone in more detail if they would like. So recap on what we've learned. Redux is a predictable state container for JavaScript applications. It has a very simple API. What I found using Redux is that the unidirectional flow of data is very easy to debug. So if you're ever at any point of your application where you're like, what's going wrong? Something's going wrong. You have a very set way of knowing what to look at. Did my action fire? Did my action not fire? If it has, then you know to look in the reducer. You can drop a debug statement, or you can put a breakpoint in your reducer. You can look at the current state. You can see what the action.type is, what the payload you're sending is. It just makes it very easy to follow the flow of how your application is working. In addition, there's a very nice tool set that Redux has. One of the things I'd like to add is that functionality in Lightning components. Locker service makes it a little difficult because there's a Chrome extension, but you need access to the window to get at that. So Locker service makes it a little difficult right now. But it's possible to put make a Lightning component that represents that Redux tool set. So I'd like to get that in there at some point. The API is kind of simple right now. React Redux has a connect API. I was trying to think of some way to incorporate that into the Lightning Redux bindings. It's not as necessary with the Redux store change Lightning event, because that's where you'll be mapping the Redux store to your Lightning component attributes. Next steps and resources. I have my GitHub repo. It's madmax983 Lightning Redux. Why is my username madmax983? Because I'm a child of the 80s, and Jack Burton 983 was taken. There's Redux documentation. It goes over everything about Redux in way better depth than I ever could. Dan Abramov actually has a free course on egghead.io. You have to sign up, and you'll get emails from him, but other than that, not a big deal. But it's like a 25 video course on Redux, so I recommend taking that because it's written by the guy who wrote it. And then there's also this repo Awesome Redux that xgromix made, and it's just a curated list of Redux resources. So it has documentation, it has blogs, it has middleware. The only thing I'd warn against is like getting gung-ho about adding middleware, because you never know when something might butt up against Locker service, and you don't want that happening. But for the most part, I found that it plays pretty well. And then also, I wanted to plug Mike Tetlow is doing a talk on Fluxy Lightning at 5 tonight. I think he's going to go over a lot of the same area conceptually without using like Redux as a specific library. So if you're interested in this topic, I'd totally recommend. I'm going to be there, so we can hang out and learn more about Lightning components and unidirectional data flow. Any questions?
I understand the how part of this, how to actually separate the state management. However, I'm wondering when do you go for this? In what situation is this case with the
So the question is when when would you choose to use Redux? And do you mean specifically use Redux with Lightning components? Okay. I think you would do it at the start of a project and not later. But really, I think it's just I mean, Redux is an abstraction. So when you're starting to do a project, you kind of are picking your technology and you're picking your abstractions that you want to work with. Is there a technological benefit to using Redux? I don't know that there is. But if it's an abstraction that you like and that your team likes and that you think will make sense for your business application, then that's when I think you would use it. And I think you get the benefits of having an easily debuggable, easily testable application.
It's more of a representation of state.
Right, correct.
And it's not really performance.
No. Right, correct. No performance that I know of that you really gain out of it. It's just an abstraction to work with to make your life easier as a developer. Oh, okay, cool. I'll take any questions after we can talk, but I've got to get the next person up. Cool, thank you very much.